I'm exercising the moderator's privilege to do a short presentation myself. I would introduce myself, but it would just make me blush. So we'll just get going. I'd like to talk for just a couple of minutes about something that's more focused for VHF than microwave, but there may be some really interesting possibilities with going higher with it. That's what we're calling the VHF plus reverse beacon network. When I moved back to Dayton a couple of years ago and went to a meeting with the local VHF group, Bob KTQK, who's one of the really active VHFers around here, asked if we could come up with a way to automatically monitor VHF, UHF beacons and report on the propagation. And he sort of was pointing in my direction when he said that, and what to look at it and thought about, could we do this? And the answer was, if the mouse is going to work, the answer was yes, but we didn't want to reinvent the wheel. So were there ways that we could use existing tools? And there are. I don't know how many of you are HF operators, and if so, if you've seen the various spotting networks. DX Maps is one very widely used website that plots DX spots on the map that come in from the packet cluster system, but also there is a large network of automated receivers that are monitoring the HF bands and decoding all the CW that they hear, beacons and operators, and forwarding that information to a database which then gets put into the DX maps. And this is called the Reverse Beacon Network. And it's been around for 5 or 6 years, I think. And it's growing. There are several hundred skimmer stations operating. And so our idea was, could we get VHF propagation data, beacon reports, and also CW and possibly PSK reports spotted into this network? The software and the websites have the capability of reporting VHF and UHF band activity, but there was not much there. So the magic of this is on the HF bands, there's a software called CW Skimmer that can look at a chunk of spectrum coming out of usually an SDR receiver, decode all the CW, pick out the interesting stuff, and format that to be either shown locally as a decoded stream or sent out to the Reverse Beacon Network database. It's Windows software. The spots include the time, the frequency, the CW speed, and what makes this interesting for VHF, UHF microwaves, the signal-to-noise ratio. So you can get a qualitative and objective, given the accuracy of the algorithm, a view of what the signal strength is like for each report. The software, it is $75, and unfortunately it's Windows, but we deal with that. And it can support up to 7 separate receivers, each of them scanning 192 kilohertz wide. It currently works on CW, and there's a version for Rtl, and that does, I think, PSK 31. And there has been a lot of work going on to integrate FT8 into the network as well. I don't know what the status of that is as of right now, but as of a couple of months ago, there was some beta testing going on, and it will probably be a separate program that ties into the others to do the FT8 monitoring, but that's very likely to be there. So again, this is great for HF, but what about VHF? Well, this was DX Maps one day looking at 2 meters back last spring, and that was all of the activity in the entire United States coming from 2 meters and above, and that's not very much. And that's typically the case. There are some skimmers in Europe that are on 2 meters and even higher bands, but the US has had virtually nothing. So we're not doing any kind of monitoring of the VHF, UHF bands. So there's no reason that should be the case, because these all support reporting for 6 meters and up. And I'm not sure why not. Maybe no one thought of it. Or maybe it's a lack of hardware, because on HF, you can go out and buy a red Pitaya SDR for less than $300, and that will record or listen to 7 bands at once to feed the CW Skimmer. So it's quite inexpensive to get a station that's monitoring multiple bands. On VHF, that's not as easy because we have bands that are separated by a lot in frequency, and you can't typically use one receiver and one antenna to suck all that in at once. So that was a problem. But it turns out there's a solution to the problem, and I think it's a really cool one. We've already talked a little bit about these things. This is the Rtl Sdr Dongle. They're $20 from Amazon.com. There are a number of companies that make these, and you can find them for less than $10, but there are also a lot of really crappy ones that are the cheap Chinese imports. This particular provider, RtlSdr.com, has designed a better quality unit. It's got a TCXO. It has a better board layout with fewer spurs, and they're available very widely. They're a little bit limited for SDR stuff. It's an 8-bit analog to digital converter, which means the dynamic range isn't great, but they're $20. And for $20, we can have more than one of them in a station. The problem is that the Skimmer software doesn't, at least the last time I looked, support the Rtl dongle at all, and it also has the ability to support only one receiver at a time. So that would be a problem if you wanted to monitor multiple VHF, UHF bands. Well, it turns out that there's a fella in New England, N8UR. He's more of an HF contester, but he had started working on software for a Raspberry Pi that would let a whole bunch of Rtl dongles plug into a single Raspberry Pi on the USB ports, come out on the Ethernet port looking like an SDR radio with 7 bands. And the CW Skimmer can talk to that. So for the cost of as many dongles as you want, a Raspberry Pi and maybe a USB hub, you can put multiple VHF, UHF bands up into the Skimmer looking like a single instance, but covering 2, 220, 432, 902, 1296. The dongles are good up to 1800 megs. Above that, you'd have to have some kind of a front-end converter, but that should be doable. This is the complete thing with 4 receivers. And this is running right now at the N8ZM contest site about 40 miles north of here. One dongle's on 6, one on 2, and there are 2 on 432, because to cover both the CW and the beacon portions of 432, it's beyond the single 192 kilohertz bandwidth. But that's kind of all that's involved in doing it. We've had some downtime with this system, but it's mainly been site problems, flaky internet, and some other issues. The radio, or the hardware itself, seems to be very reliable and runs really well. The antennas are fairly modest, because the idea here is you don't want to have a huge Yagi up on top of a mountain. To get interesting and useful data, you want signals that other people can hear. So really, it's a fairly modest antenna system. You want horizontal polarization and maybe 50 feet off the ground. And stacked halos work really well for 6.2, 432. On the tower there is the Intrepid N8ZM. Hanging the antennas we're using for 2 and 432. They're just a pair of stacked M-squared halos. And on 6 meters, we have a single M-squared halo about 50 feet up. And on 2 meters, we hear DX from kind of all of the normal radius that you would hear from this area. It's really quite remarkable. The sensitivity of these dongles is really good. And to improve things a little bit, we're using preamps at the antennas. For $20, or actually $30, you can get a preamp that goes up to 1 gigahertz, less than 1 dB noise figure. We tested it at about 20 dB gain. It's at less than $30, and they've got a bias T built in. So we stick that up right at the antenna. Now we can use RG6 or whatever kind of feed line coming down. And what's very cool is The Rtl Sdr Dongle has the ability to provide 5 volts on its antenna port. So the dongle can feed the preamp, no extra hardware required. So again, we can improve the sensitivity, use cheap feed line to make a system that's very inexpensive and works pretty well. So this is kind of what it takes to put one together. An i5 class PC seems to work really well. You need the CW Skimmer software. You need the Raspberry Pi. The Pi is running Linux and the Rtl Sdr software, which are both open source. And I have an SD card image with all this stuff set up, ready to run on my website. So you can download that, burn it onto an SD card, and you are up and running with everything taken care of. And then you need some USB stuff and some antennas and preamps and feed lines and maybe filters, but you know, hey, that's what hams do. And you need an internet connection. The internet bandwidth is very, very small. It's kind of a few hundred bytes a minute. So almost any kind of connection will work just fine. This is a set of spots from, again, back several months ago of our 2-meter spot, and showing the stuff that we received from, again, about 40 miles north of here. And unfortunately, this is not showing the grid squares. So we don't map it out as well as we can, but we're getting N4 ASF, K1 ZEB, WA4 JNP. I'm sorry, that's KA1 ZE/3. So, you know, guys from several hundred miles away coming through just on the halos. It doesn't take a whole lot. So I think the idea is that on VHF, UHF, Omni antennas can work pretty well, and you can really see how this system could work. We go up to higher frequencies, maybe we can't rely on Omnis that are going to pick up beacons from multiple directions, but if we have a path, if you can hear a beacon, you can monitor that and look at the signal-to-noise ratio over time to get an idea of what the path is like. So as we get to the higher frequencies, it might make sense to have receiver nodes that use a directive antenna pointing at a known beacon and just use it as a propagation tool for that path and detect enhancements by the signal strength rather than by the number of stations that you see, simply because there aren't enough stations that you could pick up. So at this point, we've got this site up that's been running for about 6 months now. We gave a presentation to the folks down at the VOA Club a few months ago, and they were interested in putting one up there. I talked about this at the VHF forum at Hamvention, and several folks were interested. I've not heard of anybody else actually getting up on the air yet, but we would certainly like to see each and every one of you do that. So very quick presentation, because I think, again, this is more thought-provoking for you folks. If you would like to learn more about this, I'm very happy to help, and I've tried to get as much resources as I can on the website. Be happy to talk with you afterwards, but in the interest of time, I'd like to hold off questions now, and we'll switch to our last